Hi everyone. In this video we will discuss a few problems based on motion in a straight line. Okay. So we'll look at the first problem. So we have a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta and comes to rest. If the total time elapsed is t, then the maximum velocity acquired by the car is. Okay. So what we can do, solve the problem. Let us try to represent the data in the form of a simple diagram. Let's say it started at A and then it's the motion ended at point B. So the total time taken to go from A to B is basically t. So in this total time t, for a certain amount of time, it accelerated from rest. Okay, so velocity at A was basically 0. So let's say it accelerated until C. So between A to C, the acceleration is basically alpha. Then from C to B, we have a constant deceleration of beta as given, and then finally velocity at B would become equal to 0. So since it's deceleration, I would consider it as negative, because as the body would be moving in the right direction, its acceleration would be in the opposite direction. That's why I have considered a negative acceleration. Now what is the maximum velocity? Okay, clearly as you can see, when it went from A to C, it has acceleration, so velocity was basically increasing beyond C. So the body basically has a deceleration, so body would definitely slow down. As you can clearly observe, the velocity of the body is maximum at point C. So let's find velocity at point C. Let me assume it to be v. Okay. Now what I'll consider, from A to C, let's say time taken is t1, and then from C to B, time taken is t minus t1. So if you look from A to C, if I write the equation, velocity at point C is equal to velocity at A plus acceleration into time. Okay, this is the first relation. Similarly, if we observe, okay, if we consider the motion from C to B, so C to B, final velocity is 0, initial velocity is v, plus acceleration is minus beta into time taken to go from C to B is basically t minus t1. So the idea to find the velocity v here is, from these two relations, okay, we can find t1. Okay, so once we get t1, we can find v. Or the other thing that we can do is, let's take the second relation, okay, v plus minus beta into t minus, let's write t1 in terms of v. So from first relation, we can write t1 is equal to v by alpha. So now this entire relation is in terms of so v, beta, alpha and t. So alpha, beta and t are the terms given in the question. V is the only unknown quantity which you can find. So we can basically proceed something like this. Okay. Now let's proceed to the next question. Just simplify this equation, you would get the answer. Look at the second problem. A particle starts with a velocity of 2 meter per second and moves in a straight line with a retardation of 0.1 meter per second square. The first time at which the particle is 15 meter from the starting point. Let's say it started from here, point A, moving along this straight line. Okay, so it was moving with a velocity of, initially it had a velocity of 2 meter per second, and it's moving with a retardation of 0.1. So retardation basically means that the acceleration is in the opposite direction of the velocity of the body. So since I'm considering velocity positive, I'm considering velocity to be in the right direction. I'll take acceleration to be negative, which means in the left direction. Acceleration is minus 0.1 meter per second square. Okay. The first time at which the particle is 15 meter from the starting point. So let's say the point B, A to B is 15 meters. So let's say after some time, okay, the particle B is at a distance of 15 meter from A. So basically when it goes from A to B, the displacement is 15 meters. Now the question is, the first time at which the particle is 15 meter from starting point, I'll explain what they mean by the first time. Before that, let's proceed with some equations. So we will use s is equal to ut plus half at square in order to find that time. S is equal to ut plus half into a into t square. That implies, I mean, if you observe here properly, you get a quadratic equation as you can see. So we'll get 0.1 by 2t square minus 2t plus 15 is equal to 0. Let me solve this quadratic equation. We would get 0.1 t square, I mean, minus 4t plus 30 is equal to 0. Let's multiply it with 10 or let it be as it is. So as you can see here, so we have a quadratic equation. So definitely the number of answers or the number of values of t that you might get can be 2 here. So if we solve, t is equal to minus b plus or minus root of b square minus 4 into 30 into 0.1 divided by 2 into 0.1. So we will get 4 plus or minus, I think 16 minus this 4 into 30 into 0.1 would be 12. We get root 4 by 0.2. So 4 plus or minus 2 by 0.2. So as you can see here, we are basically getting two values for t. One is 4 plus 2 by 0.2. The other is 4 minus 2 by 0.2. I think this would come out as 30 and this would come out as 2 5 10. So we got two values for t, then which is the correct answer? I mean, what do we mean by the two values of t? Okay, so if it's basically decelerating at with deceleration of 0.1, so the velocity would basically keep decreasing. Okay, somewhere the velocity would become 0 and then it would start to move backwards. So basically the body kind of passes through B at two moments, at two times, okay, at two different instants of time. So the answers that you get, t is equal to 10 seconds and t is equal to 30. So at both of those instants of time, basically the particle would be at B. At t is equal to 10, it would be at B moving in the right direction. At t is equal to 30, it would be at B but moving in the left direction. So in this question, they basically needed this answer the first time when it would basically cross that point. Okay, let's move on to the next question. Look at the question. A body starts from rest with uniform acceleration a. Its velocity after n seconds is v. Okay, the displacement of the body in the last 3 seconds is, assume total of time of journey from 0 to 9 seconds. Okay, so let's say the particle started moving along the straight line. Okay, it went from A to B. Time taken to go from A to B is n seconds. So basically what they are asking us to find is, what is the distance traveled or displacement of the body in the last 3 seconds. Okay, so let's say here the body started its motion at t is equal to 0, and as you can see it started from rest. Let's say the body was at this position at t is equal to n minus 3. Okay, so body would be here at t is equal to n. So basically this is the time frame they are referring to, the last 3 seconds of its motion. Okay, so how do we find this particular displacement? So what we will do, the distance traveled in last 3 seconds would be, so the distance traveled in the total n seconds of time minus distance traveled in n minus 3. So we can write displacement in the total n seconds minus displacement in the first n minus 3 seconds. So we can use the basic displacement formula, so which would be u t plus half into a into n square minus displacement in n minus 3 seconds would be u. For that n minus 3 seconds interval also, in the initial velocity would be that of a into n minus 3 minus half into a into n minus 3 whole square. Okay, So if you observe, basically we get a by 2 n square minus a by 2 of n minus 3 whole square. So a by 2 of n square minus n minus 3 whole square would come out as, okay, 6n minus 9. But if you look at the option, the answer in terms of v and n, but the answer that we got is in terms of n. So what we can do, look at the first piece of information. They said that it was moving with acceleration a, its velocity after n seconds is v. So we will try to express acceleration in terms of v. For that we will use velocity after certain amount of time would be initial velocity plus acceleration into time, or we can say a is equal to v by n. If we substitute that here, we will get it as v by 2n of 6n minus 9. Okay, so this is what the answer basically is. Let's proceed with the next problem. Okay, now look at this one. A car moving with a velocity of 10 meter per second can be stopped by the application of a constant force in a distance of 20 meter. If the velocity of the car is 30 meter per second, it can be stopped by this force in what distance? Okay, so let's say if you are applying a constant force, the acceleration of the body would be constant, so which means that acceleration wouldn't basically change. So I can assume like acceleration is constant. Okay, so let's assume this and proceed with solving the problem. So in the first case, as you remember, the stopping distance is basically given by v square by 2a. Okay, we are going to make use of this. In the first case, the stopping distance was 20 meter, but the velocity the particular car had initially was 10 meter per second. So I can write 20 is equal to 10 square by 2 into a. That implies a is equal to 10 square by 2 into 20, which is equal to 100 by 40. This is what acceleration is. It will come out as 2.5 meter per second square. Not the acceleration basically, this is the magnitude of deceleration of the body once you apply the brakes. In the second scenario, the velocity of the car was basically 30 meter per second. So we can write the displacement is equal to v square divided by 2 into 2.5. So 900 divided by 5. So we get the stopping distance as 160 meters. Okay. Basically in real life, this would not be the stopping distance because it's a very large value. If the stopping distance was such large value, then in that case, the body would definitely undergo collision with some other body. It's quite dangerous. Let's continue to the next problem. Two particles A and B start from rest and move for equal time on a straight line. Particle A has an acceleration of 2 meter per second square for the first half of the total time and 4 meter per second square for the second half. The particle B has an acceleration. Okay, which particle has covered larger distance? Okay, let's put the data separately and let's observe. First, particle A, particle B. So if you look at particle A, let's say the total time is 2t. Here also particle B also, the body has been moving for 2t amount of time. Let's say x to y took t amount of time. The acceleration was 2 meter per second square, and then let's say in the next half of the time, y to z, acceleration is 4 meter per second square. Time taken is basically t. Okay. Now both started from rest. Let's say the velocity at x is 0. Then velocity at y would be, if you use v is equal to u plus a, you'll get it as 2t. Okay. So the displacement in the first t seconds of time would be u t plus half into a into t square, which is equal to t square. Now let's calculate displacement in the next t amount of time. Again u. So for this interval of time t, or the motion from y to z, initial velocity would be 2t u t plus half into acceleration into 4 into t square. So which would be 2t square plus 2t square, which is 4t square. As you can see, the total distance travelled by the first body is 5t square. Now let's focus on the second body. Let's say it started it at point P. Okay, so P to Q, it has an acceleration of 4 meter per second square, where time taken to go from P to Q is basically t. So Q to R, it has an acceleration of 2 meter per second square, okay, where time taken is t. Okay, now let's if the velocity at P is 0, velocity at Q would be 4 into t, using V is equal to U plus at. Now let's calculate the distance travelled from P to Q. It would be ut plus half into 4 into t square, which would be 2t square. And then from Q to R, the distance travelled would basically be ut plus half into a into t square. So which would come out as 4t square plus t square, which is equal to 5t square. Basically, if you properly observe, the first body has travelled total displacement of 5t square in that 2d amount of time, whereas second body has travelled a distance of 2t square plus 5t square, which is 7t square. So the second body has covered a larger distance when compared with the first body. Okay. Now look at the next problem. An object falling through a fluid is observed to have acceleration given by a is equal to g minus bv. So definitely, as we studied in the fluids, the viscous force acting depends on the speed of the body. So that's why since the viscous force depends on the speed v, the acceleration of the body would also depend on the speed v of that particular particle. Hence we have a is equal to g minus bv. Now after a long time of release, it is observed to fall with a constant speed. The value of the constant speed is, okay. So if it has attained a constant speed, that means a is equal to 0 definitely. If it's moving with constant speed, acceleration would definitely be 0. If acceleration is 0, then if we use that condition, we will get g minus bv is equal to 0. That implies v is equal to g by d. Okay, so that's what the constant speed with which it would start to fall down. Okay, simple. This kind of looks like a difficult problem, but if you look at the information carefully, then you can clearly understand it's a little bit of a simple problem. Let's proceed to the next question. A stone is dropped from the top of a tower of height h. After 1 second, another stone is dropped from the balcony 20 meters below the top. Both reach the bottom simultaneously. What is the value of h? Let us try to represent a diagram. Let's assume the height of that building is given by capital H. So you dropped, let's say, a body at t is equal to 0. Let's say it reaches the 1 minute. It reaches the ground at t is equal to t. So it basically takes t amount of time in order to reach the ground. Okay. So we can basically write something like this. Time taken is root of 2h by g. Now look at the second body. After 1 second, another stone is dropped from the balcony 20 meters below the top. So if I take a point, this is 20 meters below the top. From here, another stone is dropped at t is equal to 1. So both reach the ground simultaneously, which means this also would reach the ground at t at time t. That means this one basically took t minus 1 seconds in order to reach the ground. So what I can write here, time taken by it to reach the ground is equal to root of 2 into, since it's dropped at a point, okay, from a point which is 20 meters below the top of the building, that means it's been dropped from a height of h minus 20 above the ground. Okay, this is another relation between t and h. Now we will make use of these two equations in order to find the value of h. Okay, so what you can basically do here is I hope you can simplify the equations. Please proceed with that. Okay, try that later. Before going through the solutions, before I do them, before you look at the explanation part, you try to solve the problem once. Okay. Look at this one. A body is projected with upwards with a velocity u. It passes through a certain point above the ground after t1. Find the time after which the body passes through the same point during the return journey. Okay. See, here we will use a few simple points. Let's say this is the point from where the body was projected. The speed u goes up and up. So this is the maximum height. So this is point B. That unknown point that we have, let's call it point x. So it passes through this at t is equal to t1 while it was going up. Now the question is, so at what time would it basically pass through the same point? Okay. Now it would go up and then it would start to fall down. Basically it would fall down along the same vertical line, but I am drawing separately. Now the question is, at what time it would pass through the same point during its return journey. Okay. See, if it has taken a time t1 to go from a to x, definitely when it goes from x to a, it would take the same amount of time t1. Okay, that's first point. The next thing is, you see, the total time of motion is basically time of flight is equal to 2u by g. 2u by g. Okay. So now the total time is 2u by g. Now the question they're asking us to find is time. Let's say if it crosses x at this particular point, at this particular instant while going up, after what time it will pass through the same point x while going down. Okay. So that means time taken to go from x to top and from top to x again during its return journey. So as you can see, from a to x it took t1, x2 again x back, let's assume it's t2, and again from x to a it is t1. So we can write t1 plus t2 plus t1 is equal to basically the total time of flight, which is 2u by g, or I can write t2 is equal to 2u by g minus 2t1, or t2 is equal to 2 times u by g minus t1. So if it crosses x at this particular instant of time, it would basically cross the same point x during its downward motion after that much amount of time. Okay, let's go through the next problem. Look at this one. A ball is dropped from an elevator at altitude of 200 meter. How much time will the ball take to reach the ground if the elevator is moving down with a velocity 10 meter per second? So imagine, basically write the equation, you proceed to solving the equation. Imagine this was the elevator. We need not draw such a big elevator. Let's say this is the elevator. So at this instant of time, it's at a height of 200 meter. So once you are inside the elevator, okay, let's say you are the one holding that body which is dropped. So you also have the same speed as the elevator, which is 10 meter per second in the downward direction. So if you are holding a body, the body would also have the same velocity of 10 meter per second. So in the downward direction. Once you release it, at the moment of release, the body would have a velocity of 10 meter per second downwards. So once you release, its initial velocity can be taken to be minus 10 meter per second. Acceleration is, I will consider it to be 10. Okay, and when it goes from that point and it strikes the ground, basically it undergoes displacement in the downward direction, and the magnitude of displacement is 200 meters. So this is the information that we have. We intend to find the time t. So we can use the relation s is equal to ut plus half at square in order to find the displacement. S is minus 200, u is minus 10 to t plus half into acceleration is minus 10 into t square. That implies minus 200 is equal to minus 10t minus 5t square. Solve this quadratic equation for time t. We would basically get two values of time t. So the value of t that comes out to be positive, that is the time after which basically it would reach the ground. Okay, simplify that particular equation. Let's proceed with the next question. Okay. See, here we have a balloon which starts rising from rest on the ground with a constant acceleration. Let me represent balloon with a circle. So it has an acceleration of g by 8 upwards basically. So as it goes up, its velocity keeps on increasing. Okay, and its height from the ground also keeps on increasing. A stone is dropped from the balloon when the balloon has risen to a height of h. Find the time taken by the stone to reach the ground after it's been dropped. Let's say, okay, at a height h means it's somewhere over here. Now, when it goes from that point, from ground to that particular height, okay, so it basically will acquire certain amount of velocity. Let's try to find what that velocity is. To find that velocity, I will use this relation v square minus, initially it started rising from the ground with initial 0 velocity is equal to 2 into acceleration is basically g by 8 upwards into displacement is h upwards when it goes from here to here. So v square is equal to gh by 4. That implies the velocity it would have is root of gh by 4. Okay. Now let us try to calculate the time taken by the stone to reach the ground. So if the stone was dropped at this particular position, the stone that's being dropped will have the same velocity as the balloon, which is v. Okay, so let's try to find the time taken. So it basically goes up and comes down. So this is like the initial point, this is the final point where it would touch the ground. So this is kind of displacement. So when it reaches the ground, its displacement would basically be equal to minus h. The initial velocity of the stone just after dropping is gh by 4, and once the stone is released, it would fall under the influence of the gravity. So it would basically have the acceleration due to gravity. So we can use s is equal to ut plus half a t square. S is equal to minus h, u is root of gh by 4 into time t is what we intend to find, plus half into acceleration is minus g into t square. So what's basically t square? So we kind of got a quadratic equation. Solve this quadratic equation, you would end up with the value of t. Okay, let's proceed to the next question. A body falls freely from the top of a tower. It covers 36% of the total height in the last second before striking the ground level. The height of the tower is. Okay, what's the height of the tower? Okay, let's say this is the tower that we had. Let's assume its height was h. Then in last second of its downward motion, it covers 36% of the total height. So let's assume the time taken by it to reach the ground is n seconds. So last second is nothing but nth second. So what is the distance traveled or the displacement in the nth second? Is basically, since it's going in the downward direction, the displacement would also be downwards. It's 36% of total height, or I can write 36 by 100 into h. So that's what the displacement in the nth second is, minus 36 by 100 into h. Then what's the height of the tower? Height of the tower we need to find out. Okay. So what we will do? First we will try to find the time n. We know the fact, the relation for displacement in n second, which is u. U is 0 because since it starts falling free, plus a by 2 of n minus 1, which is equal to minus 36 by 100 into h. So we would get, this is one relation between h and n. The another relation that we get is, in that n seconds of time, it falls distance h. So we can basically write the displacement is, the distance h is equal to half into a into t square. We know this. Okay. So use both of these equations in order to find the value of h. Since we already know, okay, we have two equations h and n. The thing that we need is the height h. So try to get rid of n in these particular relations. So what we can do, n is basically root of 2h by g. Substitute that here and solve the equation to get that particular value. Okay, let's proceed to the next problem. From the top of a tower of height 400 meters, a ball is dropped by a man. Simultaneously from the base of the tower, another ball is thrown upwards with a velocity 50 meters per second. At what distance will they meet from the base of the tower? Okay, so the tower that we have, it has a height of 400 meters. So at this instant, you drop the body. Okay, at the same instant, what we did, we took a body, we thrown up at it with a velocity of 50 meters per second. So definitely somewhere as this first body starts falling, this one goes up. Somewhere they would basically collide. Let's take that point as x. Now the question is, at what distance will they meet from the base of the tower? This distance we need to find. See, both bodies started their motion simultaneously at the same moment of time. So if the first body, let's say it's projected from B, dropped from B, and second body projected from B. So if first body takes a time t to go from A to x, the second body in the same time t, it would go from B to x. So the distance traveled by the first body in this amount of time is half into g into t square. Whereas the distance traveled by the second body B, in the same time we can write, if we use s is equal to ut plus half a t square, 50t minus half into g t square. So as you can see, this distance, the distance traveled by the second body and the distance traveled by the first body would totally be equal to the height of the building. So if we simplify this relation, it is equal to 400, or 50t is equal to 400, we will get t is equal to 8 seconds. So basically, once they start the motion, they would collide after 8 seconds. Now, what distance will they meet from the base of the tower? Okay, so we need to find this, basically that's the height, okay, at which they would basically collide. 50 into t minus half into g into 8 square. Okay, just simplify this relation, you would basically get that, right? 58 400 minus 64 5, it would be equal to 320. So it would basically collide at 80 meters above the ground. Let's proceed to the next problem. Now here, the velocity time graph of a body is shown in the figure. The displacement of the body in 8 seconds is. So we know the area under velocity time graph basically gives us the displacement. Okay. Since we are talking about the displacement, the area which is above the time axis, we will consider it to be positive, and the area below the time axis, we will consider it to be negative. Okay. So first look at the graph. To find the area, we will split it into smaller pieces and we'll find the area of each part, and then we'll proceed with solving the problem. So here, to find the area, let me draw a line like this. Okay. So first, let's focus on this area. So this area is basically a rectangle, which would be, its area we will consider positive. The rectangle base is 3, this height is 2, 3 into 2 basically. Let's write it directly 6. And then now I will consider this top rectangle, small rectangle, which is half into, its base is basically 1 unit, and if you consider height, it's from 2 to 6, so basically 4 units. Okay, now let's consider this small triangle. In that triangle, okay, base is 1 unit and it has a height of basically 6 units. Then look at this portion. I have to consider it to be negative. Base is 1 unit, height is basically 6 units. And then if I consider this rectangle, minus 1 into 6, and then look at this square, minus 2 into 4. So we would have 6 plus 2 plus 3 minus 3 minus 6 minus 8. So we would get it as minus, okay, so what we would get it as? 3 6 gets cancelled, minus 6 meters. Just a minute. Have we done the calculations correctly? 1 into 6, of course it's correct. Okay, this is what we will get the displacement as. Okay, I hope I haven't done any calculation mistakes. I've checked it again. I think there is a mistake with the answer. The answer that they gave is basically wrong. Okay, I think they might have given distance traveled, I guess, in 8 seconds. If you look at 8 seconds, if you wish to calculate the distance, then we do not consider the sign separately. Then we would get 6 plus 2 plus 3 plus 3 plus 6 plus 8. So we would get 10 plus 18, 28 meters. So distance traveled would be 28 meters, displacement would be minus 6 meters. Okay, I think they meant to ask distance, not the displacement. So let's look at this problem. An object is thrown vertically upwards, then the displacement time graph for the motion is given as. See, first thing, okay, so displacement time graph. Okay, here velocity of the body is not constant. So the displacement time graph would be a straight line if during interval of time, if velocity is constant, but definitely since the body will undergo acceleration due to gravity, it will not be constant. So definitely the graph cannot be straight line in any interval of time. So both option 1 and 3, the portions of the graph are straight line, indicating that they are wrong. Okay. Now once you throw the body vertically upwards, okay, so as it goes up and comes down, okay, during its entire motion it would be somewhere at a point, any point you pick, whether during its upward or downward motion, displacement with respect to the initial position would be upwards. Okay, so generally we take upward direction to be, quantities in upward direction as positive. So throughout the motion, displacement would basically be positive only. So initially during its upward motion, it basically increases displacement, and then as it starts to fall down, the displacement again decreases. So the option that correctly given here is option 2. And look at this graph. Plot the acceleration time graph of the velocity time graph given in the figure. So in this figure they gave us velocity time graph during a particular interval of time. Now we need to plot a graph of acceleration time. So first let's calculate, okay, so acceleration in each interval of time. So as you can see, 0 to 5 seconds, the velocity time graph is a straight line, indicating that acceleration is constant. Okay, and again 5 to 15 seconds it's constant, but it has a different value than 0 to 5. And then from 15 to 20 also acceleration is constant. Now 0 to 5 seconds, if you look at, acceleration is going to be, okay, a slope of this particular line. If you plot the points 0, 0, this point will have a coordinates of 5, 10, then it would be y2 minus y1 divided by x2 minus x1, which is 2 meter per second square. Then if you look at the graph between here and here, this point has the coordinates of 15, minus 10, then 5 to 15 seconds, the acceleration is going to be minus 10 minus 10, y2 minus y1 divided by x2 minus x1, which is equal to, I think we would get it as minus 2 meter per second square. And then from 15 to 20, so look at the point at t is equal to 20. This as coordinates of 20 comma 0. So the slope of the line, which would be acceleration, is given by v2, y2 minus y1 divided by x2 minus x1, which is equal to 10 by 5, which is equal to plus 2 meter per second square. These are the accelerations. Now if we plot a graph at, so definitely between let's plot intervals like this, 20. So between 0 to 5 acceleration is 2. Between 15 to 20, okay, acceleration is going to be minus 2 and it's constant, minus 2. Then 15 to 20 acceleration is going to be constant and it's going to be, here it should be plus 2. So this is what the graph is going to be. Okay. So that's the end of the problem discussion. So once, before you listen to the explanation, try these problems once. If you don't get them, then go through the explanation. Okay, that's it for the video. We'll meet in the next video again. Okay, bye.